and family members of the late engineer Basavara garu, FI, media friends, ladies and gentlemen. It gives me immense pleasure to extend a hearty welcome to all of you for making it convenient to participate today's endowment lecture in memory of Engineer I. Basavaraju, FI, past Chairman, Institution of Engineers, India. We are very fortunate to have stalwart of eminent personality, Engineer or Acharya, and we thank him for sparing their valuable time to be amidst this important event. I am very glad to inform that the Telangana State Center of the Institution of Engineers, India has been regularly organizing 17 endowment lecture every year on the birthdays in honor of the eminent engineers like Engineer V. Subbarao, Engineer M. Tirupati Reddy, Engineer Dr. J. Purushottam, Koka Krishna Mohan Rao, Engineer G. V. Subbarao, and Engineer T. Hanumantrao Garu, and A. P. Ranganath Swami, Professor S. Raghavachari, and Narla Tatharao Garu, and Mathuri Gopal Rao Garu, and Gurram Koti Reddy Garu, Atluri Venkateswara Rao, R.L. Raju, and also Engineer N.V.L. Rao, and M.L. Swami, Venkata Krishna Iyer, and K.V. Srinivas Rao Garu, and Ramakrishna. And last this year, every year, we are celebrating Engineer Basvaraju Endowment Lecture. The Endowment Lecture being developed by the people of high eminency with the considerable professional experience to throw light on important emerging topics of today's relevance. We wish to inform you, all of you, the children of veteran, our past chairman of the elsewhere AP State Center of the Institution of Engineers, Engineer I. Basavaraj, FIA, approached the State Center to organize an endowment lecture in memory of their father, Engineer I. Basavaraj, every year on his birthday. Today is his birthday, that is 30th December. Then Andhra Pradesh State Center Committee in its meeting held on 17th August 2013 has unanimously resolved to organize an endowment lecture annually at our center in honor of our and memory of veteran engineer I. Basavaraju FI, and former member technical APSCB and past chairman Institution of Engineers of our state center, who contributed significantly for the overall development of the state of Andhra Pradesh. Accordingly, the state center organized the first endowment lecture in honor of engineer I. Basavaraj on 30th December 2015. Since then, the IEI Telangana State Center also organizing endowment lecture in memory of engineer I. Basavaraj Garu on 30th December every year in this center. We are very sorry to inform that Sri I. Basavaraj Garu, past chairman of our state center, passed away on 5th December 2016. In fact, I. Basavaraj was born on Rajamahendravaram, East Godavari district of Andhra Pradesh on 30/12/1924. He was studied government arts college at Rajamandri and later shifted to College of Engineering Gundi, Madras. He passed out in 1948 in electrical engineering and was employed as a junior engineer in the technical office of the composite Madras State. Here he had the privilege to work directly under Sri VP Appadurai, renowned engineer of the time. He took charge as assistant engineer in newly formed Andhra Pradesh in 1953. At this time, he was deputed to the Germany, UK, Switzerland, and industrial for the industrial nations. The post was or Europe, and also trained in the manufacturing and operation of the power transformers and switch gates. He shifted to Hyderabad in 1956 after his training abroad. There was practically no electrification in the state except for a few major cities. He started with the electrification of 100 villages in the first year with the diesel sets under the guidance of the Shri B.R. Somayajulu, the chief engineer. He had privilege for working under the Syed Abdul Qadir and Ahmed Hussain Khan and renowned chief engineers of the electrical in that of the time. At the same time, he joined the Institution of Engineers, India, as a AMI, and he rose to FI later. He was responsible for drafting of the specification, calling of the tenders and execution for the first time 220 kV system in Andhra Pradesh and 220 kV line from Upper Sealer to Lower Sealer and Nagarjuna Sagar and Srisailam at 220 kV substations. This formed the basis for the 220 kV ring around the Hyderabad and state development. He had a very close and he's worked under the under Dr. N. Tatharao, Chairman, APLCT Board, and really he did a lot of work for the combined Andhra Pradesh. He was appointed as advisor to the Central Board of Irrigation and Power for the short period on distribution. And these few words, I am very happy that every year we are celebrating his birthday as a conducting endowment lecture. And I'm also very happy to inform that the Institution of Engineers is a statutory body to promote the advance of engineering service and technology, established in 1920 and corporate by Royal Charter in 1935. It is the largest multidisciplinary professional body of the engineers and encompasses 15 engineering disciplines. The membership of corporate, non-corporate members is almost 10 lakhs. IEI is headquartered Calcutta. The Telangana State Center has been formed after bifurcation of elsewhere Andhra Pradesh State Center since the 28 August 2016. The Telangana State Center of the Institution of Engineers on the roles of the members is then more than 9,500 corporate members and non-corporate member is 19,000. The Telangana State Center has been one of the most active center of the Institution of Engineers and which is engaged in successful translating the objects and ideas of Institution of Engineering to practice. The present Telangana State Center is the legacy of the elsewhere Hyderabad State Center of Nizam's Hyderabad State. I'm very happy to inform that the Institution of Engineers India has completed 100 years of the glorious contribution to the national development during September 1920. Now, the country is passing through the stage where the rapid economic development through the use of the latest technologies and skilled manpower is being tested upon the government. In its relative journey of 100 years, the Institution of Engineers has crossed many milestones and established its significant existence in the aggregated with the vital contribution toward the engineering education and technology advancement and industrial and economical development in our country. The activities are almost covered by the in-house programs in various engineering facets. Added to that, the paradigm shift taken place in our technology advancement in recent times, which has been brought to the new dimensions of approaching in our quest of excellency and thinking. Today, the nation is facing several technical problems all over the country. There is some areas of power crisis, water scarcity, environment hazards. Besides the problem related to many critical areas, and also at nation, it is quest for the professional excellence never stopped at the national frontier, but continuing throughout to the reach out our and occupy the rightful and diversing the position in all the prestigious works and organizing for the uh, benefit of the our society. The Telangana State Center has organized many events, the international conference in mining, present and future investments challenges in the October 2019, and international conference environmental degradation, key challenges to sustainable development in November 2019, and also prestigious event in the 100 years celebrations, 100 years, the 34th Indian Engineering Congress from 27 to 29th December 2019 also conducted here only. In addition to that, the Telangana State Center is organizing 1 day and 2 days seminars in various engineering disciplines, and we very happy to inform all of you. And still further also we are going to conduct all events, international and national events and endowment lectures. Today we are conducting the Basavara's 6th endowment lecture, being delivered an eminent person, engineer A. Acharya Garu. He has chosen a very important subject, that is a high voltage insulation system for the large capacity turbine generator. And we are all anxiously waiting to hear the talk from our eminent speaker. I am limiting myself and hope that we will really enjoy the talk. With these words, once again, I extend hearty welcome to all of you this endowment lecture. Thank you, one and all. Now I am requesting the engineer, Professor C. Ramanjanacharyalu, FIE, member IEA Telangana State Center. Please introduce today's our chief guest and speaker of today's endowment lecture, Dr. Engineer R. Acharya. Please, over Ramanjanacharya.
Am I audible?
Yes, sir, you're audible.
Respected President Dr. G. Rameswara Garu, respected Chief Guest Engineer R. Acharya Garu, respected Honorary Secretary T. Anjay Garu, and respected past presidents, chairman, council members, committee members, and family members of Engineer Basavara Garu, representatives from the media, students, if any, and ladies and gentlemen. Sabhaya Namaha, Namaskar Andarkenu. Great good evening to you all. Today, that is the 30th December, the last but one day of our Gregorian calendar 2020, which was predominated, occupied by COVID-19, where we could not meet personally. So here I have the presence on this day. I have the pleasant privilege of introducing our today's chief guest, Engineer Acharya Garu. In this contest, I am highly thankful to the President of the function, D. Rameswara Garu, and Honorary Secretary T. Anjay Garu. I am happy that Engineer R. Anjay Garu, R. Acharya Garu, he is in a BE MBA from. Am I audible?
Audible, sir, please.
Because I'm talking from iPhone, the phone, so yes. It's going because the internet is not available here. So, R. Acharya Garu is in electrical engineering graduate from NIT Roorkela with the first division honors, and MBA he has also secured it in marketing with first class distinction from JNTU Hyderabad. He has more than 37 years of experience in design and manufacturing of large capacity generators, exciters used in power plants, and he has got also experience in materials management, vendor development, and his basic specialization is in design and high voltage design. High voltage insulation system is a very, very important thing in our power systems. Everybody knows it. Because of lack of knowledge and experience in that, perhaps leads to so many problems like accidents and equipment failures and equipment burning and all the things in so many situations we have seen. Perhaps so many people might have experienced it. So it's a very critical aspect of it. So there is you are going to listen to a high voltage insulation system for turbo generators. This is a very, very important thing. And I think he will be giving a lot of inputs to us from his this thing, because we may not find it in the textbooks like written by Dr. Kin. So you can hear about it. Second thing is here. He has got so many credentials, that is, he has got he has got finance for 3 patents, and some more things are in pipeline, it seems. And he has got so many designs he has made. It more than 60 prototypes he has made in his career. This is a very, very remarkable achievement. In 37 years of service, making 60 prototypes, I have not come across so far. So this is one of the things we can think about our Acharya's lecturer. He is really an Acharya because he has studied the things and is practicing the profession in the desired way, in the desirable way. Now, apart from that, today is an important day because it is the birth date of our legend engineer of APSCB, Engineer Basavara Garu, who had many laurels in his service. Every experienced legend engineer will leave something for the future generations to learn and become better professionals in future. E. Basavara Garu was well known for his professional discipline and restrained limited talk and communication all the time. Padma Shri Dr. Tadarao Garu, one former chairman of APSCB, once directed the representatives of the media and other people who approached him from some information. He said, you go to Engineer Basavara Garu, who is the director at the time. So that means he has got so much loyalty and so much confidence of Dr. Tadarao Garu, which is very rare in engineering profession, in fact, especially in APSCB.
Okay, sir.
Second thing is, today, historically, is an auspicious day because it is the 16th day of Dhanurmasa, a pious month to plan our future activities. It is the day when Andal, with 10 more enlightened and capable friends called Gopikas, reached the palace of Nandagopa. Nandagopa is an Acharya who enjoyed the bliss of the truth, that is the Almighty, and maintained the confidentiality, a great quality of all Acharyas, for directing only the needy people in the society. Acharya Prabhu Dharma Dharmasya Prabhu Achyutaha. So, and this, the Acharyas will show the path. Now, our Acharya also will show a path for us, for the people who are needy, to develop these high voltage insulation systems. Thus, we have Acharya Garu on the birthday of another Acharya, Engineer Basavara Garu, and on the auspicious day of Acharyas, there is Nandagopa, who is the master of all Acharyas in the world. That's what we say historically. So with these few things, I hand over the things to him. I request everybody to greet our Acharya with great applause so that he can receive the salient information for high voltage insulation, which are very critical in large turbo generators, because you may use gear, you may use cast resins, or you may use some PVC, and all these things are combinations. It's a system that is going to give you now. He is going to give a beautiful lecture on that one. So let us listen to that and give him a great applause. Thank you all.
Thank you. Thank you very much, sir. Thank you. Now I am requesting Engineer Acharya Garu, please start your talk, sir.
Thank you, sir. Respected Chairman of Institute of Engineers, Telangana State Center, Dr. G. Rameswara Garu. Respected Honorary Secretary, Engineer T. Anjaya Garu, respected member of Institute of Engineers, Professor C. Ramanujacharilu Garu, all the ex-office bearers of Institute of Engineers, the chairman, the members, honorary secretaries, distinguished guests, the members of the great engineer of the undivided Andhra Pradesh, engineer Basavara Raju Garu, the family members, and all the participants. Before I start sharing the PowerPoint presentation to all of you, in the backdrop of the topic, I take this opportunity to pay my homage to late engineer Basavara Raju Garu, and for the human service that he has rendered. And it's not just the Institute of Engineers, wherein he had a long association, but as a member of CBIP and SIGRE India, I also had a brief interaction with him. And I still remember in my young days, the kind of, the unique personality that he was, the kind of service that he has rendered to this great state as well as the nation in the areas of the energy and the related fields. I also take this opportunity to thank all the office bearers and all associated members of Institute of Engineers of Telangana State and the undivided Andhra Pradesh, who are doing, obviously, needless to say, that it's a human service that they are rendering. And I know this kind of thing at least the last 30-35 years, because I joined BHL Hyderabad way back in 1983. And in different capacities, I also have remained associated. So at this juncture, when Dr. Rameswara Gauru contacted me, and a couple of my colleagues have asked me that, sir, there is a requirement of this nature. Would you like to spare some time? I must tell, it is not that I'm going to spare time, because it's the greatest of the great honor that I get an opportunity to share some of my experience with the valued members of the Institute of Engineers. So it's a learning process. Friends and all my seniors, I take this opportunity to pay my respect to all of you and your service to this great association. When the country is talking about the more of non-conventional energy, the different new areas of the diversification areas like e-mobility, hydrogen economy, nanotechnology, and all that, how is it that this particular topic would be of relevance? This is the first point that I must speak, that you all know that we started our journey as a nation, and a collective membership of all these engineers and associated professionals who have taken this country from a meager of 1362 megawatt way back in 15th August 1947. We got independence, out of which roughly around 800 some odd megawatt of thermal generation and 500 and some odd megawatt of the hydro generation. And today, from a meager, you can say 1360 megawatt of power generation, today we are touching the end of October 374,000 megawatt, that is 374 gigawatt. And what's most important is that, out of 374 gigawatt of power, the non-conventional energy occupies almost, you can say, 135 megawatt, out of which, the contribution of solar and then wind is leaping forward in a very fast way. Like you can say that almost 35 gigawatt as of now, it touches with regard to the wind generation, and almost equal amount, around 36 gigawatt in the solar generation. And in the very short time, going by the policy of the government, we are going to touch 100 gigawatt in a very short time of the solar power itself, and 187 to 180 gigawatt of power in a very short time in the non-conventional energy generation. That makes a big challenge of operating the conventional power generation like hydro and the thermal mostly, which was a couple of years before it was almost 70-75% of the contribution. Today it is almost around 60 megawatt, 60%. So the flexible operation is one of the inevitable reality, and is one of the biggest challenge right from the designers up to the power plant operators. In that backdrop, I must tell you that the ensuring a very long and reliable operation, a healthy life of the conventional turbo generators, which are operating in different conventional mode of power generation, need have to be ensured from every aspects of the design, manufacturing, and the generation operations. So I have chosen this topic, the relevance of the high voltage insulation system in a large capacity utilities, how the high voltage insulations has to be taken care of so that it ensures a very healthy and reliable life. That's the basic purpose for which I have chosen this topic. When Dr. Rameswar Rao talked to me and asked me to choose a topic relevant to the energy sector. So at this point, I will take just 15 seconds to just share my PPT.
Mahesh,
Please tell me
share option ichchaను sir.
How to share it.
Please share yourself, sir.
It is this only, no? Yeah. I have already opened this. So, no, but then I have to go to the main, here. That's okay, fine. And then
go to that this one, Zoom, sir.
Here. Here. And
your model, sir.
Is it visible to all of you, sir?
Yes, sir. Yes, sir.
So now we can start.
Yes, sir, please.
Yes, sir. Yes, sir. Please start, sir.
Thank you. Thank you.
ఫోన్లో పెట్టుకున్నా ఆయన వైర్ తీసినాడు.
So the topic, the high voltage insulation system for a large capacity turbo generator. First of all, we must understand what exactly is called a large capacity turbo generators. In fact, the definition keeps on changing. If you just talk about a large capacity generator, way back in 1950, people will say that a 30 megawatt generator is a large capacity generator. But today it is not so. After a lapse of almost 70 years, the definition of the the large capacity generators have changed. So I have just taken the world, this is a kind of the summary of the different kinds of generators in the world perspective. I have taken a summary of all the capacity of generators which are running in different utilities. When I say utilities, exclusively all of you, most of us are basically power plant engineers. You understand that the generators are the TG sets which are operating exclusively for power generation and distributing to millions of consumers. They're all utilities. Unlike the, captive power plants where the different industries. There are broadly two categories, utilities and industrial sets. And when I'm talking of the utilities, these are the different range of generators. You can see here that right from, you can say 45 MVA capacity, a typical air-cooled generator, up to, you can say 2235 MVA. 2250 MVA is the largest capacity generators which are water-cooled generators. So I have taken a summary of the different size of generators manufactured by world leaders, whether it is Siemens, ABB, GE, and so on and so forth, and Bruss. So this is the world perspective. Coming to the Indian perspective, you can see over here that the air-cooled generators are mostly today up to 50 MVA. All you can say up to 40 megawatt. Air-cooled forced one up to 250 MVA. Hydrogen cooling with a direct force up to 400 MVA. and hydrogen cooling with a water cooling system of the stator is up to 250 MVA. That is the largest size, kind of generators which are running in the utilities. And I have taken 1250 just to take, the largest capacity 1000 megawatt generator which are operating now, be offered, and some more are going to be added. 1000 megawatt machines which are for a nuclear power application, Kuram. Otherwise, the largest ones which are operating many of these, state utilities and then the central utilities like NTPC and all that, there are 800 megawatt generators. Now coming to this, suppose it doesn't, this couple of sites I will just quickly go through, thinking that as Dr. Rameswar Rao have told me that there will be a couple of students, perhaps for the students, the benefit of the students, a glimpse of different kinds of power plants which are operating within India. I have taken some slides. This is a typical view of the TG hall of a coal or a steam-based power plant. You can see over here the generator and the turbine over here. It's a typical steam-based or a coal-based power station. And you can see here, this is kind of a open cycle gas-based power station. Of course, this has been supplied by BHEL, one of the very large capacity, that is 125 megawatt gas-based power stations, wherein the gas turbines are the prime movers. This is another 35 megawatt gas pipe, gas-based open cycle mode power station, which is operating in Malaysia. And this is the view of a combined cycle operation. That means there is a gas station or a gas-based gas turbine-driven generator, and the flue gas is utilized in a like a HRSG, heat recovery steam boiler generator, and then it is feeding another. It is operating at Kovil Kalappal in Tamil Nadu. Total megawatt capacity is 104, wherein 70 megawatt gas-based generator as well as 34 megawatt of the steam-based generator. And this is, as I told you, that this is a typical 2 units of 1000 megawatt Kuram nuclear power station. This also is basically a steam generator because secondary cycle is steam only. So it is a steam generator only. Of course, I'll just quickly go through some of these slides. This is a typical view of a 2-pole 25 megawatt turbo generator, which is under assembly. And this is a view of a 4-pole smaller size 25 megawatt 4-pole machines, 1500 RPM turbo generator stator under assembly. Now these standards which really govern all aspects of the design up to the operations are the different standards, national and international standards I have just mentioned. And during the course of my further discussions on the different aspects of the insulation, they're all covered under this. Of course, the IEC standards 60034, the Indian standards, the British standards, the American National Standard Institute, ANSI, and then 2 German standards, VDE and VDI standards, and IEEE standards. These are the governing standards of the large capacity turbo generators that we are talking about. Of course, this doesn't make much of sense because I could see that most of the participants are quite experienced and knowledgeable. But then just to glance through, what we are talking about is a three-phase AC synchronous generator. This is the one out of very many varieties of the electrical machines that we have been discussing about the classification. We are talking of the large capacity turbo generators are nothing but three-phase AC synchronous generators. And there are different classification of the generators that we talk about. One is based on the drive, as I have already told you, gas turbine, steam turbine, hydro or diesel type, based on the speed or you can say frequency. Frequency in our operations in Indian condition is a 50 cycles. There are like American as well as the Middle East, there are 60 cycles operations, 2-pole and 4-pole operations. Based on the rotor construction, it can be salient and cylindrical. Based on the cooling, as I have already mentioned, that hydrogen, air or water cooling systems that are normally used basically for large capacity machines, what I have already mentioned, like 2200 MVA. They're all both stator and rotor are water cooled machines. Based on the excitation system, whether it is a DC, which is an old system, or you can say a static system or brushless system, and based on the insulation system, which the topic what I am trying to highlight is based on the thermal class of insulation. So the machines are designed whether class B or class F or whatever it is, and most of these utilities which are operating in large capacity machines, They are basically class F operations or class F insulation system. As you can see here, sir, that the power generation is, whatever you call it, a generator or whatever it is, nothing but a energy converter. Right from the coal, the stored chemical energy, to the boiler, which converts the chemical to thermal, and the turbine thermal to mechanical, and the generator is basically a electromechanical energy converter. It is not nothing generating anything. It is a converting mechanical to electrical power or electrical energy. And the basic principle on which it operates is basically the Faraday's law, wherein there is a magnetic field produced by the rotor, and there is a mechanical force given by the prime mover. And if there is a relative motion, there is an induced EMF in the coils of the stator. And by virtue of the induced EMF, it drives the current in the load circuit, that is outer circuit. The very principle, a small, simple principle. And keeping in that view, large capacity machines normally are designed with the rotor as an electromagnet, giving the required field for Faraday's law, and the stator carries the load carrying conductors, or you can say the armature, and it is the source where high voltage is induced by virtue of this, by the principle of electromagnetic induction. I have just taken a simple example for the benefit of the students who are really attending this, that if you just see the nameplate of any generator, there are different kinds of terminologies which are used, but that gives a lot of information about the generator. You can see here the kind of practice, that is T stands for the turbo generator. You can just see one nomenclature of a generator which speaks volumes about the machine itself. Like suppose you take T turbo generator, unlike hydro and other smaller speed machines, it is a high speed machines. It can be A or H or W or whatever it is. They're all hydrogen or air cooling. Then it speaks about the indirect or direct cooling, and then the dimension of the active part of the rotor and the stator. This is how normally different manufacturers, they do the nomenclature of the different generators. If you just do a dissection of a generator, if you just do a dissection of the generator, you will find that broadly there are three major components in a generator, or a turbo generator, or a large capacity or a small capacity, whatever it is. One is the rotor and the rotor associated things. There is a stator or the stator associated things, and then auxiliaries and like bearings, walkway, filters, coolers, and whatever it is. So you can see the major active parts are rotor and stator, and there are auxiliaries which are really support systems, you can say. So broadly they can be categorized into three areas. So as I have already mentioned, that the rotor acts like a magnet which produces a field or the magnetic field to interact with the winding of the stator, and the stator carries the high voltage winding. So we will be discussing in the further slides about the importance of the high voltage insulation system in the winding. As I have mentioned that, with the backdrop of my introduction, that when you are as a designer or a manufacturer or in an operation, we have to understand what kind of basic materials which are used in a typical electrical machine, not just generator. One is a structural steel, which is giving the required support system. The magnetic steel, which carries the magnetic field, whether it is the core of the stator or the body of the rotor. So all are basically, they are typically magnetic steel. There are non-magnetic steel where we don't want, or the machine will be behaving in a lesser efficient manner if you allow the flux to pass through certain unwarranted areas. So there are some non-magnetic steels available to block the passage of the flux. There are conducting materials. We know that there are rotor conductors and the stator conductors. It can be copper or aluminum. Mostly for large capacity machines, there are copper. And the last one, what I'm just talking about, which is given a chance, it can be avoided because it doesn't really give any contribution to the generation, but it's the inevitable component and plays the most important role in deciding the life of a, the turbo generator or electrical equipment. Insulating material. Given a chance that since it is not really playing any major an active role in the generation, suppose I am given an option that to minimize to zero, I'll minimize to zero so that I can maximize the size of the machine for energy generation or energy conversion. But this is something which is inevitable because fundamentally generation is dependent on the ability, like you can say the human ability or any kind of, suppose a a very energetic man. The energetic man can carry 100 kg and run. A person who doesn't have the potential, he cannot really carry a heavy load or heavy work. Similarly, the basic generation depends on the potential, or you can say the voltage. That's the reason why the basic principle starts with the electromagnetic induction or the generation of the voltage, so that the capability is built up. And to ensure the capability, you have to have insulating materials to isolate it from the earth or a zero potential point. That is the basic role of the electrical insulation in a generator. So life of depends on the life of the insulation system. In fact, if you just see the previous other materials, 4 materials, it doesn't decay much. But what happens to the insulation materials? It decays as the age progresses, and we are going to understand a little bit in a few more minutes about the role of these insulation materials. If you see the history of the insulation materials that has been used in the kind of generators, I have given some example of 30 megawatt generators way back in, let us say, 1947, or a 60 megawatt generator. Those days it was very large. But if you see the 100 years of the insulation system, broadly you can see there is a red line I have written. Prior to 1950s, or you can say at the most 1960, the insulation system which was used in the turbo generator stator winding was basically thermoplastic insulation system. And the one which is being practiced from 1960s onwards, they're all thermostatic insulation system. Broadly, there are 2 different era. The first era, what you are seeing, they're all basically the binding materials which are used are basically thermoplastic in nature. Thermoplastic, and I will give an example that, let us say, the kind of lac, what you are using, lactum, in in the olden days, or even a couple of places in in the Indian postage, for large size, the registered parcel and all that, you take a stick of lac and then put heat it up and put a few drops of it and seal it. So that is what is a practice that I think most of you must have seen in the different post offices. So that is a thermoplastic. The thermoplastic is, once you heat it up, it softens, and you cool it down, it hardens. This is the basic nature of the thermoplastic system. And contrary to that, the thermosetting system is basically thermally set. We cure it at a predetermined point and it becomes solid hard. It doesn't soften once the temperature rises. It maintains the hardness all throughout. Either it burns off or it retains its within the stipulated temperature, permissible temperature rise. It maintains the hardness, and that is what is the system being practiced. But coming to the thermosetting system, there are 2 systems that has been practiced from 1960s to 1980s, mostly for large capacity turbo generators. There are resin-rich system which was used, and in 1980 onwards, mostly the generators which are used is a resin-poor system. Resin-rich and resin-poor, that we'll be discussing a little afterwards. But basically in the resin-poor system, which is the present practice, is about the total impregnation. It was initially the bar impregnation which was practiced. Maybe it has started early 70s or maybe late 70s, and then subsequently form impregnation. And today, most of the manufacturers across the globe, they do the total impregnation because of some of the obvious reasons of its advantage. And this is what has got not only the advantage of the basic insulation characteristic, but it has got its own relevance in the present context, wherein it plays a very important role, as I mentioned already, in the flexible operation of the machines. It has got a direct bearing to ensure the healthy operation of the winding in the flexible operation when the machine runs with a very varied load. So this plays a very important role that we will discuss in the backdrop of the total impregnation of the VPI insulation system. Of course, this perhaps there was only one page, as Charulgaru has pointed out clearly, that in our college days, we never have paid much of attention, nor our professors have paid proper attention to the insulation and details of it. Even though most of us have studied engineering materials or electrical engineering materials. But then this is where we have to actually, there are 7 broad classifications, starting with Y. Of course, I have not put the Y in this because the least class, that is a example, is a common paper. So the temperature of different classification, Y, A, E, B, F, H, C, you can see they have got the maximum permissible operating temperature have been given in the degree Celsius, and the kind of materials which are actually being used as a part of you can say cotton, silk, mica, glass fiber, and then porcelain, and so on and so forth. These are the different materials which give a composite insulation of different thermal class. So coming to the high voltage insulation system, which is applicable for, you can say, uh, large capacity machines. As I mentioned in the second slide, that there are machines which are in the Indian context running from, you can say, anything between 1.1 kV up to 27 kV. A typical, like 800 megawatt machines in the Telangana government as well as NTPC projects, whatever are available. Today, they are operating with the operating voltage of 27 kV. Right from, you can say, the machines which are also there with the 3.3 kV and 1.1 kV. There are machines also operating at 27 kV operating voltage, terminal voltage. So from that backdrop, you can see that the basic objective of the insulation is to provide the required dielectric strength. What you have studied, that dV by dt or delta V by delta T. The voltage with the withstandability with regard to the thickness to withstand the voltage. The second thing in the meeting, it is not, insulation is not just electrical purpose. It has to meet the electrical, thermal, mechanical, chemical, and all the stresses, a combination of all that arising out of the machine operations. The machine life, that's why I've mentioned that it all depends on the life of the insulation system, which requires refurbishment or maybe scrapping, whatever it is. And we'll be talking about the resin poor total VPI insulation system in the few more slides, and its advantage over the previous systems and the relevance to the contemporary operations of the machines. This insulation system, whatever I mentioned in few slides before, that paper or mica or this and that, in fact, if you just look at the insulation of a large capacity high voltage of the stator winding, they are composite insulation. Mostly they're all mica based insulations, mica, glass, and the resin. Even though each and every material here has got a dielectric property, but they have got a predominant the share in the overall perspective of the insulation. While mica serves major role in the dielectric property, the glass or the glass fiber, it serves the basic carrier or the mechanical strength it gives, and the resin gives the required bondage or the bonding material between these two, because mica per se is a very fragile material, a brittle material. It doesn't, even though it has got a very high dielectric strength, but mechanically it is very poor. So it has to be carried and it has to be bonded. So as far as the resin rich and resin poor system is concerned, in the resin poor, the tapes contain almost 30 to 35% binder in a B stage. Whereas in the resin poor system, it has got 8 to 10% of the binder with the accelerator. And during the VPI process, it absorbs the required amount of the resin that has been supplemented, and it gives the required bonding strength. So this is the basic difference for resin rich and resin poor. Resin poor doesn't mean that it is poor in the final form. In the final form, every insulation contains 35 to 40% of the resin as a binder. So you can see a little clearer view of a totally VPI owned stator that has been housed in the frame. You can see the white portion is a frame, and this is the owned stator. It's a typical 120 megawatt turbo generator stator. That's what is the view. I will just get into the further details. A little quick look at the manufacturing process. This particular, whatever you are seeing, it is consisting of the stator core in which winding is placed. So you can see here the stator core of large capacity machines. I have taken the view of the stator core under building and of a typical 60 megawatt machine, wherein the man is standing in the bore of the things and going on assembling lamination by lamination, a sector of lamination. And after the completion of that, the core looks something like this. It is ready for the winding. And what you are seeing in the winding, or the stator winding, is basically a three-phase, star-connected, short-pitched, distributed, double-layer lap winding. Of course, I don't want to go into the details of this. I mean, if there are some interest, perhaps later on people can ask the questions. But as of now, there are basically large capacity machines will have either three-phase star-connected one, the individual bars are either multi-turn type or a roll bar type. But large capacity machines, you will see that anything beyond, let us say, 100, 120 megawatt machines, they're all with a roll bar design, wherein the individual strands are roll transposed, either 360-degree or 540-degree transposition using DGC copper. And there are some corona protections that has been you can see over here a typical scheme of winding, which always are available with all the power plant operators as a part of the O&M manual. It consists of the different kinds of connections, so that in any kind of eventuality, people can see this as a reference and try to address what kind of phase has gone or what kind of phase to be addressed or attended. So this is a scheme of winding. I was telling you that each and every winding consists of two separate arms, and each arm in the straight part has got the transposition. Each and every conductor is bent from top to bottom and bottom to top. That's what we call as a 360-degree transposition. As you can see over here, a pictographic or rather a schematic view of a transposition of 360 transposition of the roll transposition of individual conductors. And there are different losses that we all know, that I2R losses, eddy current losses, and circulating current losses. All these things are addressed by doing a suitable transposition and choosing the number of conductors. Of course, this is the part of the winding design, but we will go into the kind of how they're all shaped, and finally, electrically they're baked, individual stack, and then over and above that, insulation is built up. You can see over here, there are high voltage insulation system or things are built up, and they are assembled in a double layer manner, top and bottom layer, two layers of the winding. You can see there is a stack of the bars which are under manufacturing, and subsequently you can see over here, as per the winding scheme, the conductors, they're all laid inside the slots as per the scheme of winding with resin poor insulation system. I must tell you over here that the advantage when you are going to discuss at this juncture, utmost care has to be taken. Of course, I am not a doctor, but all of us know, experienced, many of us are parents, grandparents. So I must tell you that when a child is born, a human child is born, if his or her health is taken care in the initial part, when it is a child, up to 5 to 6 years or maybe up to 10 years, without any, you can say serious disease, if his health is taken care of by the parents in a very nice manner, then that child will become a very, physically very strong and live very long time. So initial 10 years is very important. So is the case with like an engineer. The engineer should understand in the VPI process how to handle the individual coils and the winding like a baby before it is impregnated and brought up as a adult. So that's what is very at utmost importance. Now we'll go to the VPI process, how the process takes place. In the VPI process, you can see over here, there is a graph that I have shown, the kind of trend, right from, you can say, how the trend has started more towards the VPI generators in the Indian perspective. Like, it all started, you can say, the early 90s. And today, almost all the manufacturers, they go for 100% VPI generators. Before 1990s, it was a combination of that, the Indian perspective I'm talking about. And then today, almost 100%, you can see a VPI generator. The VPI process is basically three broad processes. One is creating a VPI, vacuum pressure impregnation. Like first is the vacuum process, and second thing is the pressure process. And of course, these two things take care during the impregnation. And then last stage is the baking. Once it is properly baked, I must tell you that the child has become an adult and capable of withstanding all the kind of stresses. So this is basically the VPI process. VPI process is not a very, and I must tell you, not a very new process as such, as far as electrical industry is concerned. It is there even in, you can say early 70s and all that, but for a smaller capacity application. In fact, if you just see like different kinds of, impregnation process, even our old fans, fundamentally they're all dip impregnation. But for large capacity machines, even up to 21 kV application, you can see their machines are available with the total VPI impregnation, which is relatively new. Now coming to this, just to have a quick look at, once the winding is complete, the stator is placed inside a tub, a large capacity. You can see I am telling you that this is a typical view of a large capacity turbo generators, and total weight of this along with the winding and the core is approximately 137 tons. This itself is around 137 tons. It is for a typical 125 megawatt machine. First, it is placed inside and put inside a furnace, wherein the temperature is raised to 60 degrees Celsius for at least 1 hour. After that, it is put inside a vacuum chamber, and the hood is put, a vacuum, very high vacuum is created, so that the moisture, the void, and everything is sucked out. The very high vacuum to the order of around 0.2 millibar is kept for almost 16 to 18 hours. And there are qualitative checks to find out the adequate amount of vacuum creation has taken place. The winding is dry enough and ready for impregnation, or resin is let in. After that, the resin, it's a mixture of resin and hardener that is let in through a series of pipelines, and then a neutral gas of nitrogen. Normally, that is a practice almost all the manufacturers they follow. Neutral gas is put with a very high pressure, almost 4 bar, and kept for almost 1.5 hours to maximum 80 minutes to 1.5 hours. And then after that, the job is taken out. And these are the different parameters that whatever I have explained you, like vacuum drying, after that impregnation. Then we could put the pressurization so that the penetration takes place. And then the job is put in the post curing at 140 degrees Celsius for nearly 20 hours. After that, during the process, there are some kind of quality check also made to see that penetration is adequately made. There are a lot of quality checks that are made, and the job is taken out and put inside a furnace. In the rotating condition, the entire thing is cured in a furnace at 140 degrees Celsius for almost 20 hours. So entire thing becomes a solid monolith. You can see becomes unlike the previous kind of design wherein individual coils are impregnated and insulated and then put. This is the entire job is impregnated along with the core and the winding and then all the support system. That's the basic system. And then of course, after that, a lot of quality checks are made: insulation resistance, tan delta, high voltage test, and PD measurement. You can see here the job under assembly. After that, the job is placed inside, and then top cover is placed to complete the winding, and then it forms an assembled stator, and of course it goes for a complete performance test. There are some kinds of quality checks that have to be made. First is on the resin pour mica tape quality, and of course the most important thing is the quality of the resin impregnation. But it is a combination of the epoxy bisphenol A resin and a hardener, which is methyl hexa hydroxylic acid. It's an acid hardener. So they combine during this process of impregnation and form a polymer, or a polymerization takes place. So a lot of quality checks are made by the manufacturer to see that the resin is always suitable. It's the same resin is, you can say, a typical 135 to 140 tons job. When it is impregnated, it takes almost 60 kiloliters of resin and hardened mixture. And this is a reusable resin that has been practiced for a large capacity machines. And the advantage of the VPI insulation system, this is which is actually the most important in the present relevance. It's a very high mechanical bond, a void-free insulation, a high dielectric strength, a low dissipation factor, or you can say tan delta, very low dissipation factor, hence longer electrical life, a better heat transfer, because that is another point wherein actually the whatever heat is generated due to the I square R loss and all that, it has to be effectively dissipated out, so that that is possible only when an insulation, which is a electrical insulation, should be a good thermal insulation. This is good as through good thermal conductor. That is the most ideal thing, and that is possible in case of a high vacuum pressure impregnation system. It requires less maintenance, and it is very cost effective. You can say the elastic response. This is what I wanted to highlight, that one important factor of the VPI insulation system because of the elastic response. When machine runs at a different loads due to the flexible operations, naturally the stresses, thermomechanical stresses will be there in the winding and the core. The adherence and the bondage. If the bond breaks, then there is a possibility of mechanical damage, thus resulting in the electrical failure. Whereas this machine maintains a good high flexibility, resilience, thus this is suitable for a very high, then that's the reason why, very frequently this is adopted for a gas turbine applications, wherein the machine is designed to run almost 3 to 4 shifts in a day. It has got a low inflammability, so that any damage that takes place, the damage extent is very less. Very high resistance to oil, alkali, and moisture. To be very, to talk, it is like a fit and forget. Unlike, other kind of insulation system where individual bars are placed, here it is supposed not to fail at all. It is fit and forget. It can, in fact, used as a submerged one. You can water jet also, it can operate. That's the kind of the advantage of a total impregation system. You can see here when the IEC standards what I have referred to, it permits almost 2% of tan delta at 0.2. It actually gets almost 0.7, 1/3 of the total permissible value. This is one advantage of a total VPI insulation system. You can see over here different kinds of void-free insulation system. Normally, with a machine with a high, the resin-rich insulation system, individual bars have got more of voids, whereas for a resin-poor insulation system, total one, it has got a almost void-free insulation system. One important thing to the operators, basically power plant owners, what is the advantage to them? It is a long service life, less maintenance, because it doesn't require, unlike the resin-rich system wherein individual coils have to be inspected, the tightness has to be checked off every yearly, you have to plan for a maintenance and all that. It doesn't require maintenance even for 5 years. If it is properly taken care, 5 years, no maintenance. It just open and see what exactly cleanliness and put it back. So there is no need to check any tightness, no wedge checking, nothing of that nature. It is a complete monolith. That's the kind of advantage of a total BPI insulation system. And that's the reason why the overall lifetime cost to the power plant operators is very, very negligible as far as generator is concerned. But what are the hazards and the risks? Many people, couple of years before, when you were introduced at VHLR Sipuram, NTPC, I was taking a session, and most of the senior executives were told, what happens when it fails? I told why it should fail. I was given that example that Hero Honda motorcycle. Of course, I am not a marketing person of Hero Honda. Hero Honda, when they came with a 100cc bike, they told, fill it, shut it, forget it. That's the kind of, if you remember, when we were young people, we were operating, like the Vespa or the Chetak scooter, 2 liters, 3 liters and all that. Whereas when we, went for the, 100cc bike, Hero Honda was one of the things. They fill some 10 liters and you forget for 700 kilometers. But they claim that it was 70 kilometers per liter. So I also told that fit it, shut it, forget it. That is the kind of insulation system that the VPI system offers. But if there is a failure, obviously it's a very tedious process. The winding repair is a tedious process because you cannot. We have to do a local repair. We cannot bring back the complete benefit of the BPI insulation system. And second thing is the disposal of the resin. As I told you that resin is again and again used, but at any point of time we require almost 60 ton or 60 kiloliters of resin. And after some time, because of the higher viscosity rise and all that, penetrability will not be there. That's the reason why the manufacturer has to dispose of almost, you can say, 60 kiloliters of resin. That is a big issue and environment issue and all that. But there are opportunities of using this used resin in the different low voltage insulator applications and recycling and all that. These are the different environment risks of this kind of insulation system. But this insulation system is the one which is applicable today, even up to very large capacity machines, up to 400 MVA and all that, up to 21 kV applications. And there are the research that is going on to see that it can be made more and more conductive by adding some fillers like metal oxides, so that it becomes electrically insulating but thermally good conducting, so that the insulation thickness can come down. Friends, I just want to tell you that in the turn of the last century, when the generator were made for 11 kV application, a typical thermoplastic insulation system requiring almost 7 to 9 millimeter insulation, radial thickness on the conductor for a typical 11 kV application. Today in the 21st century, for the advent of this high voltage insulation system, we are using for the same 11 kV class only 1.7 to 1.8 millimeter insulation. Imagine the kind of progress that the insulation has made in the last 100 years, from 11 almost 7 to 9 millimeter insulation radial thickness to almost 1.8 to 1.9 millimeter insulation. And perhaps in the time to come, if there are more research in the area of the conductivity of improvement of the insulation, then we can further trespass 1 millimeter insulation barrier for a typical 11 kV application. I'm just giving an example. With that, I think I've taken almost 35 to 40 minutes of your time. I thank you all for giving a patient listening, and whatever little that I've learned about this, I've shared with you, and with my experience at different power plants as a part of the member of BHEL, I've traveled across almost more than 100 power stations here and there. We have got more than 150 sites. So I have noticed that I have got the pride to share with you that many of our own collaborators and then world leaders like GE or Siemens and all that, the VPI insulation system record of BHEL as a company is the failure rate is much lower than even our own collaborators. That's because I have already mentioned that in the process, when the child is very young, you take care of that. Then your child is just fit and forget. That's the kind of thing you have to take utmost care in the resin management, the resin poor tapes and all the storage and all that kind of quality checks, very meticulous planning, and that can give you a much better reliability. Thank you all. Thank you once again, institutional engineers and the officials to have given me an opportunity to share my few learnings in my life with regard to this. That's a very vast topic, no doubt.
Yes,
Given an opportunity to share with all of you. Thank you all the participants for a patient listening.
Thank you very much, sir. Really, it is very informative and interesting and technical talk you have given, sir. Really, time is not really, it is required minimum 2-3 hours, sir. It is very interesting, sir. Really, please give the big round of applause to our sir. I'm requesting all the members. Please give. Really, sir, it is very interesting.
Thank you all.
Sir. Very
Thank you all, sir.
Sir.
And
sir,
if anybody has got any question, I'm ready to answer.
Sir,
choice is yours, sir.
In general, the endowment lecture we don't.
We don't give
scope for the
time. Okay, sir. That's fine.
Sir. One day again, we will call you, sir, after pandemic, our institution. Definitely, we want your talk. We will call all the students, college students after pandemic. And
yes,
one day seminar we will conduct, sir. That day we will invite as chief guest, sir. Please give the once again this presentation, sir. We will invite the all college students that day.
Yeah, that would be a good thing. And Dr. Rameshwara Garu, you can share my email ID. I think it is there with you now, sir.
Yes, sir. Right now I'm having.
You can share with all the participating members if they like to interact something in some way, some of the interest.
Yes.
I'll make a humble attempt to reply whatever little I have learned. And then it will be my pleasure. Thank you all.
Definitely, sir. Definitely, I will.
Thank you, sir.
Now I am requesting our Under Secretary, Engineer T. Anjaya, please propose vote of thanks, sir. Sir, one thing, sir. Today we are having this son, sir. Our I. Basavara son is there. Please, sir, you want to say anything, sir? Sir.
We are grateful to the Institution of Engineers Chairman, Secretary Garu, Anjay Garu, Rameshwara Garu, Ramanujacharya Garu, and the honorable guest. The family members express their gratitude to the Institution of Engineers and to the honorable speaker. Thanks.
Namaste, sir. Namaste.
Sir, today we are having our All India Chairman Rajmani sir also there, sir. Our All India Division Board Chairman, sir, Electrical Division Chairman is there, sir. Sir, please say a few words, sir, Rajmani sir.
I express my gratitude from the family members of I express my deep gratitude.
Sir, unmute. You can unmute yourself, sir. Rajman sir. Yes.
Very much for giving me an opportunity to talk to you during this occasion. After a long time, we have been listening a topic on the electrical machines. So it is a wonderful subject that you have invited the chief guest for this today's function. So I thank you for giving me the opportunity to all the electrical engineering members to know their own subjects. So far we have forgotten about electrical. We have been dealing with the electronics and communications and other things, renewable sources and all those things. Today we have gone to our original subject of electrical machines. Thank you for giving this opportunity.
Thank you, sir, for attending also, sir. Thank you on behalf of Telangana State Center. We are very thankful you, sir, for attending this today's our endowment lecture, sir. Now, anybody want to talk about our
Sir, Professor Ramna here.
sir?
Professor Ramna here, sir.
Okay, please, Ramna, talk.
Sir, thank you, Acharya sir. It's a highly appreciable presentation, and we are proud of you, sir. As an Institute of Engineers, we have been several times to BHL also. My colleagues are there, sir, Mr. Narsimha and Balaji. The man who working in these college of pride, sir. Really, sir, we have been to Kalpakam also. And thank you, sir. We will take your immediately with our chairman, sir, and we will be touching, sir. Thank you. Good day, sir. Advance happy new to you.
Thank you. Yes, sir, you want to say, sir, Raj, sir? Raju, sir. Dr. ISN Raju Garu. Okay. Now we are closing, sir.
Sir, I want one question.
Okay. No questions in endowment lecture.
No,
Just
clarification.
Tell about
clarification.
చెప్పండి అజయ్ గారు టైం సార్
Acharya Garu,
sir,
this insulation is a very important topic for this high capacity turbo generators, no sir? So I remember that in the Teraja book, R is equal to rho L by A, that in insulation resistance, sir. Am I correct, sir? So
no, sir. Actually, that exactly the Ohm's law, whatever you have studied, R is equal to rho L by A. Mostly they are applicable for conductors.
Conductors, yes.
And not the insulators. I have talked about the insulator, sir. Insulator has got, of course, I have not touched with a limited time. If somebody wants to know about more of the insulation, then we have to talk about the insulation resistance.
Insulation resistance.
That has got a different equation, sir. What you are told, sir, it is basically applicable for a conductor. And the rho, what you are talking about, is basically the resistivity of the conductor.
Yes, sir.
Thanks.
Now, the insulation which you have used is, previously we used to use Dr. Beck insulation. Now we are using for different parts, or they completing all winding once for all?
Sir, good question, sir. But I must tell you that Dr. Beck and Co. doesn't, Dr. Beck and Co. the different types of resin and the varnishes, what they are making at Pune, they are not applicable for a total impregnation system. The resin and hardener, whatever I have mentioned, we are importing from German sources.
Okay.
That is Bakelite, Germany. And there is one more source that is available in Switzerland and Austria. So Dr. Beck and Co. basically makes the varnish. They don't make impregnating resin. I want to clarify.
Okay, sir. Thank you, sir. Thank you, sir.
That Dr. Beck and Co. that resin and then varnish, whatever they are there, they are basically suitable for a low voltage applications like fans and then all that, which is a very low voltage. Whereas what I'm talking
for 100 HP motors also we have used it, sir. For rewinding.
That's true. That is Dobecon series they make. But if you just look at it, the applicable voltage is very, very less. Whereas what I'm talking about, a very high voltage applications.
Okay, sir.
Sir.
Hello, Rameshwar garu. Just I want to share one line about Basavara garu. Hello. Hello.
Dr. Rameshwar garu, please unmute yourself and then.
Sir, please cheppandi, sir. Hello.
Hello, Rameshwar garu.
Cheppandi, sir.
ఇది బసవరాజు గారు యాక్చువల్గా 2015లోని ఎక్స్ప్రెస్ ఇంటెన్షన్ టు హ్యావ్ ఎండోమెంట్ లెక్చర్. సో వీ హ్యావ్ గాన్ టు హిస్ రెసిడెన్స్. మన స్టాఫ్ అంతా కూడా అప్పుడు ఆయన కొద్దిగా మూమెంట్ లేకపోతే ఇంటికి పోయి ఆయనతో మాట్లాడాము. సో మాట్లాడితే యాక్చువల్లీ ఈజ్ డిజైర్ యాక్చువల్లీ ఇట్ వాజ్ ఎండోమెంట్ అయింది. తర్వాత ఐఎమ్ టోల్డ్ దట్ ఈజ్ సచ్ ఈజ్ ఎ వెరీ హంబుల్ పర్సన్. సో ఇన్ స్పైట్ ఆఫ్ హిజ్ హై దిస్ వన్ ఆల్సో he developed our institute when he was the chairman, and the hostel block was constructed during his tenure of the proceedings of one of the Indian Congress. And for his first endowment lecture, the then APSCB chairman has attended as a guest speaker. That is his stature and all the things. You are very fortunate to him have a chairman, and He is a role model for all of us. Thank you very much.
Thank you very much, sir. Now, Anjay garu, please propose the vote of thanks.
Sir, respected chief guest and speaker of Engineer I. Basavara, 6th Endowment lecture, Engineer R. Acharya Garu, dignitaries on webinar, distinguished guests, fellow fraternity, family members of late Engineer I. Basavara, media friends, ladies and gentlemen. Sir, am I audible, sir?
Yes, yes, you are audible, sir. Please go ahead.
It gives me immense pleasure to perform the pleasant duty of proposing vote of thanks. On behalf of the Telangana State Center of Institution of Engineers India and on my own behalf, I convey our sincere and profound thanks to Engineer R. Acharya, General Manager and HOD, Head, Corporate R&D, BHL Hyderabad, who made it convenient to be with us today and delivered Engineer I. Basavara 6th Endowment lecture on a very important topic on high voltage insulation system for large capacity turbo generators. I convey our thanks to the guests, fellow fraternity, and our past chairman, committee members, budding engineers, and who made it convenient to participate today event. I also thank the family members of Engineer I. Basavara Garu, who made it convenient to attend this important function. I also thank Professor C. Ramanujachari Garu for introducing the today's chief guest to elite participants. I thank the management of media for their continued support to all our endeavors and activities. Once again, I convey thanks to one and all. Thank you very much.
Thank you very much, Anjay sir. Thank you. Now we'll close by Janaganamana.